First big deal is getting customers into VVols. And we're going to do this in a pretty straightforward way. Can we go ahead and roll that second demo? Here we go. All right, so we're back to our environment. We've got our 6 database servers. We can see here that there's no storage policy applied to it. So let's take a look at the storage policies. One of the things that's exposed through VASA 2 is this ability to build policies and then pull capabilities of the storage array directly through it. One of the ones that we built in, obviously, is going to be QoS. So we can look at the policy here, and we can see that we've set min, max, and burst for both data and config VVols, right? So if what we want to do is move a VM from a VMFS data store into a VVols data store, we can go ahead and do that with any number of things. In this case, we're going to choose an 8-line PowerShell script that's going to go through and identify the VMs, migrate the VMs, and apply the QoS policy that we need to, right? That PowerShell is going to work no matter what the vendor is, right? So it's a VMware technology. As long as we have the ability to apply the policy and remediate the policy, we're going to see that. So where we are now is everything's been moved in and it's all in a single policy, which is where we would expect a traditional storage buyer to be, right?
And the thing to notice here is that it's kind of like noted on when we started, what's called move, right? So you're moving a VM from one place to another. And that's the big thing here. Moving data is not good.
Right, so we migrate in once. Now what I'll promise you is for the rest of these demos, this will be the last time that we move data. We're going to do lots of stuff. We're going to do lots of moving performance around. We're never going to move those blocks of data again. We're never going to have to do a storage vMotion again in order to be able to move those. So we've moved them in. We've created the VVols, so we've created the volumes on the SolidFire storage array. We've applied the policy to the volumes, and you can see our 2,000, 5,000, 10,000 that are in there. And if I was a traditional storage, if I was not a SolidFire customer, this would be the end of my VVols migration. I've got one tier of storage that I put it on, but I've got 3 disks on each of these VMs. So what if I needed different performance for my log volumes versus my data volumes versus my home directory volumes, right? My swap volumes, those sorts of things. So in this case, what we're going to do is we're going to show something that we would be able to do if we had a multi-tiered system. So if we had a gold, silver, bronze, slow disk, medium disk, fast disk, I could build this same 8-line PowerShell script and I could move this stuff around, but in order to implement that, I'm going to move data. Right, so we're going to have to vMotion those from one tier of storage to the other. SolidFire wants nothing to do with that, right? Changing performance is an API call. It's not a data movement process. So we've got our same PowerShell command script here. We're going to implement that PowerShell script, and what you're seeing is we are putting policy on, remediating, and then checking compliance for every disk on every one of those 6 VMs. We did that with no data movement. We did that, as you can tell, with no involvement from the storage team, right? We didn't have to go do that from the storage array. And now I can look and see that I've got 3 different policies that are applied to the 3 different disks that are sitting on those VMs. I can see that I went from 2,000, 5,000, 10,000 to 6,000, 10,000, 12,000, and all of those are maintained. So no matter how many more VMs I would provision in there, all I have to do is consume the performance and capacity of the entire cluster.
And just to put a little context on that, I didn't see anyone's eyes go Google Gaga for what just happened. If you think about what it's required to achieve that in a traditional environment, it takes time, it takes people to approve things, it takes the right time to do it, and it takes a lot of risk that you can potentially take in any infrastructure to move that amount of data and how much it is. It's a lot of manual work that you're eliminating by doing things in place and only having to manage, in this particular case, one volume, one container, right? That traditional model is multiple LUNs, multiple volumes, which is a problem. This is all done in one single storage container, and you can deliver that through API calls, which is pretty impressive when it comes to being operationally efficient and reducing risk at every level.
So we can do